Hello everybody. Today I am going to start a new video series which is on the electrodynamics. So what I am going to do in this series is I will it is like a course on the electrodynamics, the course that one uh, get introduced in his BSc or MSc level physics. So it is going to be a complete course. uh, so what are the things that I am going to explain in this videos? Let me introduce you. So let me first remove this. Okay, so first of all I will explain the basic mathematics, that is okay, the basic mathematics that that is required to study the electrodynamics. Okay, so here in the mathematics part, what I am going to introduce is the first of all the entire the electrodynamics uh, can be explained with the mathematical concept called the vector analysis. But we can also study the electrodynamics, like we can derive the Maxwell's equation with the concept like the tensor. So this tensor is something that I am going to explain after the electrodynamics. So what I am going to do, let me explain, is first of all I'll explain the vector analysis, and in the vector analysis I will explain the concepts like for example the basic vector algebra and all this all the concepts in the algebras, like for example the how the vectors are added, how the multiplication, the dot product, the cross product in the vector, the displacement vector, the separation vector, and how the vector transform. After that I will explain the differential calculus. So in the differential calculus I will explain like the gradient, the del operator, the divergence, curl, the product rule, the second derivative, and all these things. And then I'll move on to the differential calculus. I'm sorry, the integral calculus. Which includes the line integral, surface integral, volume integral, and the some of the fundamental theorems like the gradient theorem, the divergence theorem, Stokes theorem, and all this thing, because these are the theorems and these are the things that we will get encounter when we study the electrodynamics. After that I will explain about the other kind of coordinate system, a brief introduction about the other kind of coordinate system, like the spherical polar coordinate. Okay, so it will be the coordinate system, spherical polar coordinate, and the cylindrical coordinate, and we'll generalize this coordinate for the we will generalize this coordinate and we will call it the curvilinear coordinate. So we'll see the how this coordinate, a special kind of coordinate system like the Cartesian and Cartesian coordinate, the spherical polar, and the cylindrical coordinate, their equations can be derived from this curvilinear coordinate system. Okay, we will also see a little bit about the Dirac delta function. I must apologize for you about my handwriting, because I'm using this you know the writing tablet first time in my life, so please pardon me for my handwriting. So these are the mathematical part. Okay, so after that, after this, I'll start the whole theory of electrodynamics. So these theories will goes like this. So yeah, one thing, I'm not going to explain the tensor. uh, just after this Dirac delta function, I'll after this Dirac delta function, I'll move on to the entire electrodynamics. So first of all, I'll explain the electrostatic part. So first thing we learn after that is the electrostatic part. So what I can say is that what I can say that the entire electrodynamics can be separate out into three different levels. Like first is the electrostatic part. Here what it means that if the electric field of a system is independent of time, then how the entire the stories of the electrodynamics will goes on. This is what we are uh, going to be witness in this electrostatic. In the similar way, we have what we call the magnetostatic. Similarly, if we have magnetic field which is the time independent, then how the entire story of this electrodynamics will go on, will get to know in this magnetostatic part. After that, if we have a time dependent electric and magnetic field, then only we will going to learn about the electrodynamics. So one thing that I have done a mistake. So instead of writing this as a electrodynamics, I can write it as a electromagnetism. Okay, so okay, so in the electrodynamics, so this static term will become the dynamic term. So dynamic means we have time dependent, I'm sorry, time dependent B and T term, B and E. If we have a time dependent magnetic field and the electric field, then how the how we can just modify this electrostatic and magnetostatic. Okay, so so for example, let me tell you one thing, one interesting thing. Like for example, from the very high school physics, we have learned the Coulomb's law. And we have also learned the the in the magnetostatic we have learned is the Biot-Savart law. I think there is a mistake, spelling mistake in this. Let me see what is the correct spelling. Okay, so it is Coulombs, Coulomb's law. So actually this Coulomb's law and the Biot-Savart law are the solution of the Maxwell's equation. Okay, so what is Maxwell's equation? Definitely we are going to learn after the electrodynamics. Okay, so after the electrodynamics we will move on to the Maxwell's equation. Trust me, the entire electrodynamics can be summarized with this, just by these four Maxwell's equations.